graders, and welcome to the final lesson of this week's material for math. Go ahead and please get out your math notebooks and turn to a clean sheet, name and today's date. Let's go ahead and review our objective today. I can use Pythagorean Theorem to solve real-life application problems. Previously, we talked about square roots and how they apply to the Pythagorean Theorem. But let's go ahead and review. So Pythagorean Theorem, once again, is a squared plus b squared equals c squared. That's something that we've been talking about, and that's something that's kind of old hat. Now, however, we're going to need to use it to solve real-life application problems. Let's say, for example, that you have a ladder that is 13 feet. You place it exactly 5 feet from the wall. You need to place the banner, so let's say we have a banner that is 10 feet above the ground. Is the ladder long enough? So, in doing this, what we can create here is an application problem that requires us to use Pythagorean Theorem. So, I'll give you a minute to have this copied. Alright, let's go ahead and use our units and solve for us this application problem. So, we have a ladder. Now, ladders, we know, in order for them to work, we sometimes have to lean them against buildings. So let's say this is my building. And I lean the ladder up to the building. What this does is it creates for me a right triangle. So we know that our ladder is 13 feet. That can be our hypotenuse. And we know that in doing so, we get the distance from the ladder to the building is 5 feet. That could be one of our legs. And we have a poster which is 10 feet high in the ground. That could be another leg. So in doing so, so the question that probably many of you are having is, Mr. Campbell, we already have all the units. And you're correct. The question though it's asking though, is this going to work? So in using Pythagorean Theorem, let's plug in our values. So taking C for 13, A for 5, and B for 10, let's figure out, does this work? Do these three values make a right triangle? If both sides are equal, then yes, this works. If it doesn't, however, then the answer is no, this is not right. So, in doing so, let's review. So, we plug in for A for 5, so we get 5 squared plus B, which is 10 squared, equals C, which is 13 squared. So, A squared, which is 5 squared, is 5 times 5, which is 25. 10 squared is, once again, 100. And 13 squared is, anyone? Anyone? 13 times 13, let's just make sure that I am correct here. Is 169. 25 plus 100 is 125. So does 125 equal 169? That is incorrect. You're right. So the answer is this ladder tall enough to hang this poster? The answer is no. Let's say, however, using our ladder problem, let's say we have a ladder though. And let's say this ladder is, instead of it being 13 feet, let's say it's 20 feet. And it reaches up to a height of about 12 feet. And we want to figure out how far that shadow the ladder makes from the building to where the ladder touches on the ground. In doing so, we've also created another application problem using the Pythagorean Theorem. Once again, C, our hypotenuse, is going to be 20. B is going to be 12 squared. And a is going to be x squared. So now you have x squared plus 12 squared equals 20 squared. Let's go ahead and solve this. So 20 times 20 will give me 400. 12 times 12 is 144. Plus x squared. Now, in order to get x squared by itself, we have to subtract 144 from both sides. So now 400 minus 144 equals 256 equals x squared. And again, in order to get that squared, what do we do, 8th grade? That's correct. We take the square root of both sides. So 256 squared will give me the value of 16. So the shadow that is created is 16 feet long. When the ladder that is 20 feet is draped and it reaches to a point of 12 feet. Very good. Let's go ahead and do one more problem and then we'll work on our exit slip. Let's say now instead we don't know how long of a ladder we need, but we know we want to reach a value of 20 kilometers high. And we know we want to be able to reach a shadow that is 15 kilometers long. So again, using Pythagorean Theorem, we don't know what c is. We can make 15a and 20b. So 15 squared plus 20 squared equals c squared. 15 squared will give me the value of 225 plus 20 squared, which again we've done since we did our previous problem, is 400, equals c squared. So adding them together, 225 plus 400 will give me the value of 625. And again, in order to get that squared off our variable, we have to square root it. So 625 squared will give me the value of c being 25 kilometers. Very good. Your homework will be posted on Google Classroom dealing with problems just like this using the Pythagorean Theorem. But let's go ahead and answer our exit slip, shall we? And again, if you have any questions or concerns, please feel free to reach out to me via email. All right. Your exit slip is the following. Let's say we have a friend named Kendrick, and he's interested in purchasing a television. We all love TV. We also all love smartphones. But let's say he wants to purchase a TV. And he has picked out a specific section on a wall on which to mount that television. The wall space measures 2 feet tall and 3 feet wide. Okay? So, sizes of television are given in inches and describe the diagonal length. Can Kendrick fit a 42-inch television on a space that he has picked out? So, we need to fit a 42-inch TV, and what we're looking at is, does this dimensions of our mount going to work with the TV we want to make or purchase to mount? I'll go ahead and pause the video right now to go ahead and answer this question. All right. Well, first things first, we have a problem here. We have feet and we have inches. So, the first thing we need to do is we need to take 3 feet and 2 feet and convert them into inches. So, in doing so, we know that 3 feet, how many feet are in an inch? 12 inches in a foot, you are correct. So, in multiplying 3 times 12, we get 36 inches. 2 feet, so 2 feet, again, times 12 will give me 24 inches. All right, so we've taken 2 feet and 3 feet, And we've created now, so we have 36 inches. And we have 24 inches. So now what we're needing to find is the diagonal, or the hypotenuse, for this television, this mount. So, once again, 24 will be A, 36 will be B, and X will be C. Let's use the Pythagorean Theorem to solve this. So, 36 squared plus 24 squared equals X squared. 36 squared is 1,296. 24 squared is 576 equals X squared. Let's go ahead and add those two values together. So we get a grand total of 1,872 equals X squared. And again, in order to get rid of that squared, let's take care of that. So X equals 43.2. All right. Now, this is perfect because this hypotenuse is the diagonal of our mount. It's going to be wide enough to fit that television that is 42 inches. So can we fit this television on our mount? The answer is yes. Yes, we can. Join me next week when we look more into using Pythagorean Theorem to solve more application problems and use it to find more geometric figures. Tune in.